Good morning, everyone. Welcome to physics class. In the last lecture, I gave introduction about equations of motion. So there are three equations of motion. And I told you about two conditions that are necessary for that equations of motion to be applicable. That means if those two conditions are not fulfilled by object, then you cannot apply equations of motion. So what are those two conditions? First one is acceleration should be constant, right? And second, motion of the object should be in straight line. And these two conditions, if I summarize, I can tell them as uniformly accelerated motion. That means this equation of motion is only for uniformly accelerated objects. There only you can apply it. After that, I derived first equation of motion. I told you why we take that assumption. Now first equation of motion is V equal to U plus AT. And I derived that equation using velocity time graph in the previous lecture. And this equation, if you see it carefully, is nothing but formula of acceleration. Next is your second equation of motion, which is position-time relation. And that also I will derive using same graph. So if you see here, this is the velocity-time graph. Velocity on the x-axis and time on the on the y-axis and time on the x-axis. And this is your origin. And your object, it is initially having some velocity u, so it is starting not from the 0 but from u. U is the initial velocity. And then it moves from point D to point B, where its velocity becomes v, and going from D to B, that object is taking t seconds. So from 0 to this point C, this OC is nothing but t seconds. Okay. Now, for the second equation of motion, that is position-time relation, we have to find distance or position using this velocity-time graph. So I will wrap these two conditions. Before starting with derivation, one important thing that I want to tell you is, whenever you have, let's say, distance-time graph, using slope, you can find out velocity, right? If you have velocity time graph, using this slope, you can find out acceleration. So let's say in case of velocity time graph, if you have to find distance, then what you will do? So to find distance using velocity time graph, area covered by this line gives you distance covered. Okay. So to find area covered, what you have to do? You have to simply drop a line over here. Now this is the area covered. And if you can find this area, then you will get distance. Okay. So to find distance from velocity time graph, I have to find area covered by dB. Okay. So let's start. Now if you see here, area covered by line DB. So I have dropped two perpendiculars, and the area covered, if you see, is nothing but ODBC. Okay, what I am doing here? I am finding second equation of motion, position time relation. And if I have to find position, that means I have to find distance covered by object. I have to find area covered during D to B. That will give me distance. Okay, so this is a way to find out distance from velocity time graph. Finding out area covered by that line. So here if you see, area covered is nothing but ODBC. Right, this is the area covered. And what is this? This is your trapezium. So distance here, I can write this as area covered, and area covered is ODBC. Okay, and what is this ODBC? If you see the shape, this is nothing but trapezium. But here, instead of finding area of trapezium, what I will do? I will divide this trapezium into two parts. If you see here, you can see it consists of one triangle and one rectangle. So what I will do? I will divide this trapezium into triangle and rectangle. So I will find area of this triangle. Then I will find area of this rectangle. I will add these two, and that will give me area of trapezium, which is nothing but distance. So distance I can write as S, which is nothing but area of triangle. With triangle DBE. So I will write here DBE plus area of rectangle. Rectangle ODEC. So this is rectangle ODEC. Okay. Now, what is area of rectangle and area of triangle? Area of triangle is half into base into height. And area of rectangle is length into breadth. So let's see this thing from this graph. Okay. So area of triangle DBE. What is base here? D to E. Okay. And what is height? BE. Okay. So I will write here half into base is DE into height is BE. This is for triangle, and same for if I have to write for rectangle, length into breadth. Length you can take either OD or you can take EC, rectangle. So opposite sides are equal. So I will take OD and OC. So OD multiplied by OC. Hope up to this point is clear to you. I have simply divided trapezium into two parts, triangle and rectangle. Now let's find out DE. If you see here, this is rectangle, so DE is equal to OC. And what is OC? OC is here from 0 to T, that is T. Okay, so DE I can write, so if you see here, DE is nothing but equal to OC, which is nothing equal to T, that is O to C. BE, what is BE? What is height of BE? So BE is going to equal to AD, right? So I will write here BE is equal to AD. And what is this AD? This AD. Either you can do like this, AD is OA minus OD, right? You can write AD as OA minus OD. And what is OA minus OD? It is V minus U, right? Your O to A is V, your O to D is U. And for rectangle, OD is U and OC is C, right? So your OC I have already written. I will write OD also. It is nothing but U. So now this, I am going to write this in this equation. So S is equal to, this is not big, small. So half into DE is T, BE is V minus U, V minus U, okay, and then plus OD into OC, that is U multiplied by C. Okay, now what is this V minus U? Now what I am going to do is, instead of this V minus U, I will write this in terms of A. Okay, by using first equation of motion. What is first equation of motion? V equal to U plus AT, right? So if you see first equation of motion, V equal to U plus AT. So this I can write as v minus u equal to at. Simply I have taken this u to this side. So instead of v minus u, what I will write? At. Okay. So let's write it. Okay. So s is equal to, half is already there. This is t. Instead of v minus u, I am writing at and plus u multiplied by t. So these are variables. I will remove this multiplication sign. So this is a, t into t become t square by 2 plus ut, or simply just rearrange it, ut plus half at square. So this is your second equation of motion. S, that is the distance, is equal to ut plus half at square. Hope this is clear to you. Now let's move to third equation of motion. So third equation of motion is relation between position and velocity. So this is v square equal to u square plus 2as. There is no time here. Okay, so simply you have to find relation between position and velocity. So I will rub this this part. Okay. So here also you have to find position. That means what you want here is distance. So same thing here, distance, we already know this from second equation of motion. Distance is area covered by this trapezium, that is ODBC. Now to find position velocity relation, what I will do is, I will simply write formula of trapezium. What is formula of trapezium? Sum of parallel side, half into sum of parallel side into height. Right? So now if you see here this ODBC trapezium, which one are parallel sides? This one and this one. Right? So first, okay, what I will do is S equal to half into sum of parallel side into height. Hope this you know. So half into, what are parallel sides? OD and CB. So OD plus CB. And height is OC. So I will write here OC. Okay. So this is your trapezium. You know this is trapezium, and this are parallel side, and this is height. Okay. So now what is OD? U. What is BC? B to C. BC is equivalent to AOV. Right? So first I will write OD. OD is U. Okay. This BC or CB, which is equal to OA, which is equal to V. And what is OC? It's nothing but C. From O to C. Okay, so we'll put this in this equation. So half into U plus V into T. So what I told you is, you have to find relation between, not position time, this position velocity. We don't want time here. Okay, so I have to remove this time. Okay, so again I will use first equation motion to remove this time. So this first equation of motion, V equal to U plus AT. So I will rearrange it little bit. This I will take to this side, V minus U. A I will take, so this is AT. Now A I will take here, so V minus U upon A equal to T. So what I can write from first equation of motion, I can remove this T by writing, instead of T, V minus U upon A. Okay. So now I will write here. So S equal to half U plus V instead of t, I am writing v minus u divided by a. Okay. So now s equal to this 2a, I can write like this. So this is nothing but v plus u, v minus u. Now you have to open bracket and solve it, and this 2a I will take to this side. So 2as here. So v square minus vu plus uv plus minus is minus, so minus u square. This 2 will cancel, they are same. So 2as equal to v square minus u square. Or I can rearrange in that way. So this I take to this side. Your equation become v square equal to u square plus 2as. So this is your third equation of motion. So from a single velocity time graph, I have derived three equations of motion, assuming this is for uniformly accelerated object. And this three relation we use to find out variable which are missing or which are not defined in this question. Like sometimes position and velocity is given, you have to find time, that you can use. There you can use which numerical, which equation we can use, that depends on that numerical. Okay, what is given in that numerical, which equation we can fit there. When we do numerical, this equation will be more clear to you. And as I told you earlier, we have taken certain assumptions here, and that assumption is important because that makes complicated situation simple and easy to understand. Okay, and it is like all other factors are very negligible. So we can neglect them and we can assume that situation like perfect one. So this much for today. In the next lecture, there is one more topic left, that is uniformly circular motion, uniform circular motion. So, I will cover that part. There is a little bit of introduction. After that, we will start with numericals and questions. We will try to solve many numericals as we can, because then only you will gain understanding of how to use this equation. Thank you.